For this week's post-lab questions, you will write molecular equations, total ionic equations, and net ionic equations for all reactions that took place. This means that any two solutions that generated a product and you wrote it in your table, you will have to write equations for it. So first, you need to write your molecular equation. And I'm just going to do the very first example, which was between NaOH and H2SO4. Okay, so we know that all of our reactions are metathesis, double displacement reactions, and we know that two ions are displaced, making two new compounds. So we know that it's Na and SO4 and water. And this is where your solubility rules become very important, because the products you form must be identified as soluble or insoluble before you can complete your total ionic equation. And when it's soluble, it's represented by writing AQ, which means that the salt is aqueous or dissolved in water. And since we have water as our product, we know that one is aqueous. And insoluble would be represented by writing an S next to the formula in your molecular equation. Now, if you look at this, you can tell it's not balanced. So, we need to look at it again. And since we know that Na has a +1 charge and SO4 has a 2- charge, this becomes Na2SO4 and H2O as our products. But it is still not balanced. So we know we have to add a 2 from this Na over here. So it's 2 NaOH but it's still not balanced. So we add a 2 right here. And now you can check it, and it is balanced. After you get your balanced molecular equation, you can write your total ionic equation. In the total ionic equation, you need to represent everything from your molecular equation as ions. After you write it all out, make sure all your ions are balanced. So we just want to break this up into H+. Don't forget your states. 2-. And since there's a 2 in front of this NaOH, we want to make sure we carry the 2 over to the OH as well. And we already know that this broken up looks like this. H2O liquid. Okay, and you can look at it and tell it's not balanced. So we need to look at whatever we have to make sure we need to have the same amount on both sides. So since there's a 2 right here in front of the Na, we add a 2 right here. And we have 4 hydrogens on this side. We only have 3 on this side. So we put a 2 in front of this H+. And make sure you check it, and now it is balanced. So the next thing we do is we look for our spectator ions, and these are the ions that are found on both sides of the equation and can be canceled out because they're the same. And in this case, our spectator ions are SO4, 2-, and 2 Na+. Now we can write our net ionic equation. In the net ionic equation, we want to show any product that does not exist as an ion. And in this example, it's H2O because it's a liquid. But any solid or liquid needs to be in your net ionic equation at all. So let's go ahead and write everything that was left over and include our liquid H2O. And since there are 2's in front of all of these, we'll cross them out. And our net ionic equation is H plus aqueous plus OH minus aqueous H2O liquid.